One Wonka bar, please.
Which one have you?
I never had a Wonka bar. I always dreamed of it. Even after the contest had ended, I never had. What do you recommend?
How about a method of spot?
A math bibliopsis spot? How does he do?
My dear boy, do you ask a fish house?
No.
Or a bird flies?
No.
No, siree. They do it because they were born to do it. Just like Willy Wonka, how he was born to become a candy man. As you were born to be a Wonka.
Actually, could I have one more Wonka bar from my Grandpa Joe? He used to work out here before the store closed. I'm sure he would love the taste of Wonka's chocolate.
Sure. Tip the equation extra milk chocolate bar on the house.
Thank you. I got the lucky 5th golden ticket.
I congratulate you, little boy. Well done. You have found the 5th golden ticket. May I introduce myself? Arthur Slugworth, president of Slugworth Incorporated. Now listen carefully. I'm going to make you very rich indeed. Mr. Wonka is at this moment working on the fantastic invention, the everlasting gobstopper. If he succeeds, he'll ruin me. So all I want to do is get hold of that one everlasting gobstopper and bring it to me so that I may find the secret formula. Your reward will be 10,000 of these. Think it over, Willy.
Greetings to you. The lucky winner of this golden ticket. Solve the following math problem and present this ticket at the factory gates. Use the table to graph each function. 2. Use an appropriate number of values for x. Y equals the absolute value of x minus 3. Y equals the negative absolute value of x plus 3. Y equals negative x to the 2nd power plus 4. Bring a chaperone. See you there. Willy Wonka. Oh boy! Look everyone, look! The 5th golden ticket is mine!
Pulling on our legs, Charlie.
Here,
Let me
Grandpa, see for
it.
yourself.
Read it, Joe, for heaven's sakes.
Greetings to you, the lucky finder of this golden ticket from Mr. Willy Wonka. Solve the following problems and present this ticket at the factory gates. You may bring with you one member of your own family, but no one else. In your wildest dreams, you cannot imagine the marvelous surprises that await you. Charlie, you've done it!
I can't believe it.
It says I can bring one more person. I'd like to bring you, Grandpa. You're the closest to a father I ever had.
Sure thing, kiddo. But first, we need to solve the math problems.
Math problem number 1. To solve the following problem, y equals absolute value of x minus 3, you have to do the following steps. Your objective is to create and use a table to graph each function in which you need to choose sets of x that include negative x values. First, create a 5x3 table chart in which one column is used for one of the 4 values being used. The second column is actually the substitution of the x value into the equation, and the last column is used for the coordinate pairs. Second, choose 4 x values that include negatives. For this example, I will use -4, -1, 0, and 3. Whatever x-intercepts you decide to use, make sure that you add the first column to your left. Third, input and substitute the x values into the equation. For example, when I input the -4 for the x value, try to find the absolute value of -4, which is 4. And then subtract the value by 3, which equals the 1. Same thing applies for the other variables. The absolute value of -1 is 1. So 1 subtracted by 3
Is -2.
The absolute value of 0 is 0. And then subtracted by 3 equals to -3. And the absolute value of 3 is 3. And the 3 subtracted by 3 is 0. Next, transform the x and y graphs into an ordered pair. So it's -4, 1, -1, -2, 0, -3, and 3, 0. Lastly, graph the ordered pairs. So, -4, 1, -1, -2, 0, -3, and 3, 0. Also, classify which type of line it is, which either linear, exponential, quadratic, polynomial, and or power types of functions. That's it. Now you know how to graph functions.
Willy Wonka, Willy Wonka, the amazing chocolatier. Willy Wonka, Willy Wonka.
Thank you everybody. Welcome to the factory. Can I now see your guys' tickets, please?
Hi, my name is Nicole.
Hi, I'm Willy Wonka. It's very nice to meet you. Who's this?
I'm Veronica Sol.
Hi, my name is Willy Wonka. It's very nice to meet you. You must be Augustus. I'm Willy Wonka. It's very nice to meet you.
Nice to meet you too, with my mom.
I'm Mrs. Cool. It's nice to meet you, Mr.
Charlie Bucket. Hi, my name is Willy Wonka. It's very nice to meet you. I read about you in the papers.
Ah, I'm Joe Bucket.
Hi, my name is Willy Wonka. It's very nice to meet you. Shall we?
Mr. Wonka,
Yeah?
how much further?
Just over yonder.
Mr. Wonka,
Yeah.
what happens if we win?
That's a surprise. As you guys can see here, this is a classroom. Please do not touch these donuts.
Mommy. That's my precious little darling. Is he crazy? I mean, he keeps rambling about math problems and not about candy. More importantly, money. Besides, my feet are killing me.
Everything is okay. I'll buy you 15 of the most comfortable stilettos money can buy.
But Mommy, I don't want stilettos. I want pumps. Either way, Mr. Wonka said I look nice in them.
Good. Get on his good side so we can take over the company.
Okay, I'm gonna go use the restroom. Please do not touch anything. Do not touch those donuts. And I'll be right back. Free donuts! My dear boy, what are you eating?
Oompa loompa doopy doo. I got a perfect problem for you. Oompa loompa doopy doo doo. If you arise, you'll solve for me.
Yes, sir, indeed. You must graph the following problem. Y equals the absolute value of x minus 3, or you'll be asked to be prohibited from these grounds.
I don't know how to do this, but I'll give it a go. I think I did this correctly.
Sorry, dismiss.
What Augusta did wrong with the problem was that he didn't graph the absolute value function equation correctly. There are two ways to graph an absolute value equation. The best way to graph y equals the absolute value of x minus 3 is to the following. Before we start, please note that absolute values always make an angled line. First, your vertex starts out at the origin, which is 0, 0. Next, note that if any operation is in the inside of an absolute value, it will factor where the x-intercept of the vertex is, while any operations outside that absolute value will factor where the y-intercept of the vertex goes. For example, since this is y equals to the absolute value of x minus 3, your vertex starts at the origin of 0, 0, but then the vertex will go down 3 times, so the vertex will now be 0, negative 3. Next, since you know the point of vertex, find more ordered pairs by going up a slope of 1 and mirroring it on the axis of symmetry. And that's how you graph absolute value functions.
Since this place is ruined, we'll go to the next destination of our travel.
Mommy? Yes, my dear. I want a student.
You have 47 dogs, 34 cats, 14 roosters, 11 gerbils, and 2 lions. A bear, a zebra, and a giraffe, and that dumb squirrel. Gosh, worst times with that squirrel.
But doopity doo, I got a perfect problem for you. But doopity doo, if you were right, you'll solve for me.
You can have this, slave, if you solve the problem y equals x squared minus 4.
Whatever. I think I am done. Yeah, for me. Give me that.
Wrong. Oompa Loompa, escort her out.
Oompa loompa doopity doo. Oompa loompa doo.
Yeah, we did it. What did they do wrong this time?
Solve the following problem. Y equals x to the power of 2 minus 4. Your objective is to create and use a table to graph each function, in which you need to choose 4 sets of x that includes negative x value. First, create a 5 by 3 table chart. One column is used for one of the 4 x values being used. The second column is actually math by substituting x value into the equation, and the last column is used for the final coordinates. Second, choose 4 x values that includes negatives. For this example, we will use
-3,
-1, 0, and 3. Whatever x-intercepts you decide to use, make sure that you add to the first column to your left. Third, input and substitute the x values into the equation. Like for example, when I put -3 for the x value, try to find -3 squared, which is 9. And then subtract the value by 4, which equals 5. Same thing applies for the other variables. -1 squared is 1, and -4 is -3. 2 squared is 4, and then -4 equals 4. And the 4 squared is 16, and then -4 is 12. Next, transform x and y graphs into an ordered pair. So, -3, 5, -1, 3, 2, 0, and 4, 12. Lastly, graph the ordered pairs. So, -3, 5, -1, -3, 2, 0, and 4, 12. Also, classify which type of line it is, which is either linear, exponential, quadratic, polynomial, and or power types of functions.
It was very nice meeting you.
Wait, you promised me a prize.
Well, sorry, you guys didn't win. You guys stole something. So I'm
You
sorry.
stole something? But Mr. Slugworth promised me a lot of money.
Slugworth? You're kidding me, right? I mean, you guys are dismissed.
We're leaving, Charlie. If Slugworth wants his gobstopper, then we'll...
Wait. Mr. Wonka, here you go.
What? Why?
Because it's the right thing to do.
Mark Clement.
Hi.
Mark Clement?
Charlie, do you know what happens for people that get what they wanted?
What?
They live happily ever after.
I never had a Wonka ticket. Lick you.
Thorn was here.
Speak louder! Look, see for yourself.
I can't do this. Okay, wait.
Jonah.
But
Who is this young lady? I don't know.
and I, his
Oh my god, I got it!
Shut up!
Go.
Look, everyone, what are you doing?
Oh my god, it wasn't recording this whole time.
Oompa loompa.
Stop.
You should say like
Okay.
What?
Wait, I heard laughing. You have to
Stop, Johnny! What? That's crazy.
You guys seem so
Limp.
How do you live?